Now, if we had a V2 and a V1 both linear, could we be sure that those graphs meet? Well, linear graphs are straight lines. Now, linear graphs could have the same slope, but not share any points, okay? If they have the same slope, and there's any point on this one that's not on this one, then none of the points of this one are on this one. And if we have two velocity functions, one with a positive slope and one with a negative slope, and the slope, of course, is the coefficient of t, then clearly they don't have the same slope, and any two lines that don't have the same slope do have to meet. And that's fairly obvious. If you have a parabola and a straight line, because in the example I gave you, the v of t function would be parabolic, so for example, if this was a t squared here, well, it's possible to have a parabola and a straight line that don't intersect. Or to have a parabola and a straight line that intersect at one point, and that would be a point of tangency to the graph. I didn't draw that very well, but you understand what I mean. Or, badly drawn parabola, but you understand the picture, you'd have 2 points of intersection. And 2 is the maximum for a straight line and a parabola. And you can prove that algebraically. Fairly easy to prove, although you might not have been able to ask to do that many proofs. Okay, so there's kind of a picture of what you can get when you have this sort of model, do your integrations and so forth. If you want to find out when the velocities are the same, you set your velocity functions equal. Depending whether you have straight line or parabolic or even worse, types of velocity graphs, you then have some idea how many points of intersection you would have in the graphs, where they might be if you can locate the axis of symmetry and so forth, and the intercepts, and slopes of straight lines, where the points of intersection of the velocity graphs, two different velocity graphs might be, or where the points of intersection of two position graphs might be, telling you when the velocities might be equal or when the positions might be equal. Okay, well, kind of an overview. Main thing I wanted to illustrate was the possible usefulness of this diagram, this type of diagram, and basic characteristics of linear and quadratic graphs that can illuminate a problem for you in a way that you might not otherwise see.